In this video, I'm going to show you how to use the One-Way ANOVA in SPSS statistics. As you can see from the table here, One-Way ANOVA is a parametric statistical test of case samples that are independent of each other. Parametric assumptions to meet the distribution of the samples must be normal. The variances of the samples must be equal, and it must be using parametric data, that is, interval or ratio level of measurement. Let's answer some problems. An ecological study was conducted to compare the rates of growth of vegetation at 4 swampy underdeveloped sites. These are 4 groups, 4 samples. Determine the cause of any differences that might be observed. Part of the study included measuring the leaf lengths at a particular plant species on a pre-selected date in May. 6 plants were randomly selected at each of the 4 sites. So, first question. Why is One-Way ANOVA appropriate to use in the answer question posed? One-Way ANOVA is appropriate to use because we are comparing 2 or more samples, groups. Recall that the test and estimation procedures, analysis of variance, and normally distributed. Why might you feel reasonably confident that your data satisfy the assumptions? So let's test for normality. I'll input the data first in SPSS. Now I'm going to test for normality, analyze, descriptives, explore, locations factor list, leaf lengths dependent list. Okay. To test for normality, take a look at the skewness ratio for all locations. Divide the skewness statistic to the standard error of the skewness. Now, since all of these locations are less than 2, therefore they are normal. How about the homogeneity of variance? Now let's compute for the homogeneity of variance using the Levine's test. Analyze, compare means, One-Way ANOVA. Make sure the locations will be on the factor list, leaf lengths dependent list. Options, homogeneity, post-hoc, 2 key, hit OK. Homogeneity of variances, the p-value is 0.443. Levine's test. Levine's test. P-value is equal to 0.443, which is greater than alpha of 0.05. Therefore, the variances are equal. The samples are normal and the variances are equal. Now, the null alternate hypothesis would be HO. Could be either the groups, all of the groups are equal, or group 1 is equal to group 2 is equal to group 3 is equal to group 4. Alternate hypothesis would be at least one pair of locations is different. Let me change this alternate hypothesis to be at least all of the locations are equal. You can also state the alternate hypothesis to be not HO. From the ANOVA output, what is the p-value, and do the data provide sufficient evidence to indicate that they're different? Let's go back to the output. P-value is 0.000. The p-value is less than 0.0005. This is also less than alpha of 0.05. Therefore, the data, since the p-value is less than 0.05, we reject the null hypothesis. So at least one pair of locations different. Data provided sufficient evidence to indicate a difference in the mean leaf length among 4 locations. Use the p-value to determine in favor of the null hypothesis. Yes, the p-value is less than 0.0005. It's also less than alpha of 0.05. Therefore, we can reject the null hypothesis. State the results of ANOVA in context, that is, do the ANOVA results suggest that mean length varies function of location? Yes, the ANOVA results suggest that the mean leaf length varies as a function of locations. Is it necessary to conduct a post-hoc test? Yes, since we reject the null hypothesis, we need to find out which pair of groups is different from each other. Yes, it is necessary to conduct a post-hoc test. If so, report the results and interpret. We just go back to the output. Since we've enabled post-hoc test, we're just going to find the location pair that has an asterisk. Those with asterisk means that there is a difference, there is a significant difference. So location 1 and 3 are different from each other. 1 and 4, 2 and 4. So let's take note of that. Location 1 and 3, location 2 and 4, location 3 and 4, location 1 and 4. So these are all the locations that are different. Locations 1 and 3, location 2 and 4, location and location 1 and 4, a significant difference from each other. So these are the groups that prove the alternate hypothesis that at least one pair of locations are different. Let's try another example. An experiment was conducted to compare the effectiveness of 3 training group programs, ABC, So One-Way ANOVA, because multiple groups. 15 employees, n is equal to 15, were assigned 5 each, but not each person was required to assemble 4 pieces of equipment, average length of time. So these are the average length of time done to assemble equipment. Some of the employees are assigned during the course of the program, so it's possible to have an invalid case in using the One-Way ANOVA. Why is the One-Way ANOVA appropriate to use in the question posed? Same answer. One-Way ANOVA is appropriate to use because we are comparing 2 or more groups. Evaluate the tenability of normality assumption. So we're going to test for normality. Like what we've done before, let's input the data. Assembly. So now we're going to perform the normality test using the skewness ratio, analyze descriptive statistics, explore. Now let's move assembling time dependent list, training program, factor list. Skewness ratio. Now since the skewness ratio of all 3 of them is less than 2, means the samples are normal. The tenability of the normality assumption is tenable. Use the Levine's test. Let's use it. Go to Analyze, Compare Means, One-Way ANOVA, Factor of your training program, Assembling time, Dependent list, Options, Homogeneity Variance test, Post-Hoc Test. So the Levine's test indicates that the p-value is equal to 0.880. Levine's test p-value is equal to 0.880, is greater than alpha of 0.05. Therefore, the variances are equal. Levine's test indicate that the variances are equal. Therefore, the homogeneity of variance assumption is tenable. State the null and alternate hypothesis for determining whether or not the assembly time varies a function or whether they are enrolled in training program A, B, or C. The null hypothesis would be the assembly time of group 1 is equal to the assembly time of group 2 is equal to the assembly time of group 3. The alternate hypothesis would be at least one pair of a pair of training programs is different from the others, or simply not HO. What is the F value and P value associated with the ANOVA test? So let's go back to output. The F value is 5.704. the p-value is 0.025. Use the p-value to determine whether or not you should reject the null hypothesis. The p-value of 0.025 is less than alpha of 0.05. Therefore, the null hypothesis can be rejected. States the results. That is, the ANOVA results suggest that assembly time varies as a function of the training program. The results of the ANOVA concludes that the data provided sufficient evidence that assembly time varies as a function of the training program. Now this is the alternate hypothesis. So another alternate hypothesis could be the assembly time varies as a function of the training program. And another null hypothesis could be the assembly time does not vary as a function of a training program. Is it necessary to conduct a post-hoc test? Yes, it is necessary. We need to find out which pair proves the alternate hypothesis. Let's go back to the output. Post-hoc test. Now again, let's look for the asterisk. So the pair of B, training program B and training program C is significantly different from each other. And that's it. The post-hoc test results indicate that the training program B and C is significantly different with each other. This is how to perform One-Way ANOVA in SPSS statistics. For more tutorials on statistical analysis using SPSS, please save this playlist and subscribe to my YouTube channel. Now if you have more questions or any problem sets to solve, just comment down below. Thank you.